Overload. 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 Overload.
Hey everyone, welcome back to my channel. It's been a while, but I'm excited to dive back into creating content, starting with an important topic, e-waste management. Today, we'll explore the impact of e-waste on our environment and discuss practical solutions. So let's jump right in. I'm Preeti. I'm a first year Computer Science and Engineering student at Sri Venkateshwara College of Engineering, Bengaluru. As I said earlier, today we are discussing e-waste management under the guidance of Ms. Sunita Rani. In today's lineup, we will discuss e-waste and its sources, composition of e-waste, toxic materials used in manufacturing electronics and electrical products, impact of e-waste on humans and environment, e-waste management, challenges in e-waste recycling, innovations in e-waste management, global initiatives for e-waste management, and conclusion and call to action. As we all know, electronic waste is abbreviated as e-waste, and e-waste refers to electronic products that have become obsolete or reached the end of their useful life. The sources of e-waste includes discarded devices like smartphones, computers, TVs, and other electronics. Composition of e-waste. E-waste is majorly composed of metals about 60%, pollutants 3%, printed circuit boards about 2%, CRT and LCD monitors about 12%, cables 2% and 5% of metal plastic mixture, 15% of plastics and other waste materials about 1%. Toxic materials used in manufacturing electronics and electrical products. Lead, mercury, cadmium, and brominated flame retardants are the four major toxic materials used in manufacturing electrical products. Lead, commonly used in solder, contributing to soil and water pollution. Mercury, found in batteries and switches, posing serious health risks. Cadmium, present in rechargeable batteries, causing environmental contamination. Brominated flame retardants, used in plastics, impacting ecosystems and human health. Impact of e-waste on humans. Electronic waste contains toxic components such as metal and chemicals that are dangerous to human health. This includes mercury, lead, polybrominated flame retardants, cadmium, barium, and lithium. These toxins can damage skeletal, nervous, and reproductive systems of the human body, which can lead to diseases and birth defects. It can damage human blood, kidneys, central and peripheral nervous systems. It increases rate of attention deficit or hyperactivity disorder, that is ADHD, behavioral problems, changes in child temperament, and sensory integration difficulties. Now let's see the impact of e-waste on environment. Soil. E-waste that is disposed of in regular landfills pollutes the soil. When e-waste decomposes in the soil, harmful heavy metals such as lead and cadmium are released, contaminating crops and microorganisms. Water. E-waste also contaminates groundwater. Toxins in this waste are harmful to animals, plants, and communities. It becomes difficult to find clean drinking water. Air. Improper e-waste shredding and melting releases dust particles such as dioxins, which pollute the air and harm respiratory health. Burning e-waste releases small particles that might cause cancer and chronic ailments. E-waste management. E-waste management includes four major steps. They are collection, pre-treatment, recovery and recycling and disposal. So the first step is collection. Here we collect the e-waste from unorganized and organized sectors. And the second step is pre-treatment. Pre-treatment includes many processes like size reduction, separation and dismantling. Recovery and recycling. Recovery and recycling includes many alternatives like hydrometallurgical, pyrometallurgical, biometallurgical, physical recycling and thermochemical recycling. Disposal methods includes landfilling and incineration type of disposals. Now let's discuss the challenges in e-waste recycling. Technological complexity. Complex devices pose challenges for extracting valuable materials. Exportation of e-waste. Mismanagement leads to the illegal exportation of e-waste to developing countries. Lack of infrastructure. Some regions lack proper facilities for e-waste recycling and disposal. Innovations in e-waste management. Electronic recovery techniques. New methods are designed to recover precious metals and reduce energy consumption. Robotics and automation. Advanced automation is used for disassembly and sorting, enhancing efficiency. Blockchain for traceability. Blockchain is employed to track the entire e-waste management process transparently. Global initiatives for e-waste reduction. So the three major global initiatives are legislation implementation, educational campaigns, and corporate responsibility. So the first one is legislation implementation. Several countries have enacted laws to regulate e-waste disposal and recycling. Educational campaigns. Awareness programs aim to educate the public about responsible e-waste disposal. Corporate responsibility. Businesses are encouraged to adopt sustainable e-waste management practices. And now we are at the end of our session, so let's recap and outline our next steps. So the first one is shared responsibility. Addressing e-waste is a collective responsibility of individual, business and governments. Sustainable solutions. We must prioritize sustainable methods to improve the efficiency in e-waste management. Environmental protection. Strategically implementing recycling practices and reducing e-waste generation to safeguard our environment. Thank you for watching. Please do like and share the video.